The students are going to convert a copper oxide compound into pure copper by allowing it to react with methane gas. They will be able to use their data to calculate the empirical formula of the compound. The students find the mass of a test tube to be 33.05 grams. The paper will keep the copper oxide from touching the sides of the test tube. Now that the students have added the copper oxide to the test tube, they are removing the paper. They find the mass of the test tube with the copper oxide in it to be 34.29 grams. Notice that they are careful to keep the copper oxide in the bottom and off the sides of the test tube. The students are adding methane gas to the test tube, which they then light at the mouth of the test tube. The students carefully heat the copper oxide. The methane gas will react with the copper oxide to drive off the oxygen, which reacts with the methane gas to produce carbon dioxide and water. Only copper is left in the test tube. While the copper metal is cooling, the students continue to add methane to the test tube to prevent the hot copper from reacting with oxygen and turning back into copper oxide. Notice that they continue to burn the excess gas coming out of the mouth of the test tube. The students find the mass of the cooled test tube after the experiment to be 34.04 grams. Notice the metallic luster of the copper as the students rub it on the lab counter.
Now, let's determine the empirical formula of our compound using our data. Remember that we were told that our compound is some copper oxide. So, our formula is going to be Cu something, O something. So we are going to need the mass of copper and the mass of oxygen. Once we figure out these masses, we will convert to moles and then find the simplest whole number ratio of the moles. Work with your lab group to figure that out. Local teachers, please pause the tape for your students to complete the conclusion questions of Lab 2. So, you found the empirical formula to be CuO, which is copper 2 oxide. When asked to find an empirical formula, you will either be given percent composition or actual masses. If you are given percentages, you assume the sample is 100 grams to simplify our calculations. So 50% would be 50 grams. You then convert grams to moles and go from there. If you are given masses, you just convert grams to moles and take it from there. Let's try one more of each of these types of problems, and then we'll call it a day.
Complete this problem in your notes. Determine the empirical formula for a compound that's found to contain 32.37% sodium, 22.64% sulfur, and 44.99% oxygen.
Now convert each of these to moles. Check your work. Now write the formula using the moles as subscripts, then divide by the smallest subscript to find the simplest whole number ratio. You should have found the empirical formula to be Na2SO4. As you've previously learned, that's the formula for sodium sulfate. Try one more in your notes. Determine the empirical formula for a compound containing only phosphorus and oxygen, in which a 10.15 gram sample contains 4.433 grams phosphorus. First of all, determine the grams of oxygen. So you have 5.717 grams of oxygen. Now convert each of your grams to moles. Check your work. Now write the formula using the moles as subscripts, and then divide by the smallest subscript to find the simplest whole number ratio. Did you run into a problem? The subscript on oxygen is not close enough to a whole number to round. This is an easy problem to solve. Remember that an empirical formula is the simplest whole number ratio of the elements in the compound. All we need to do here is multiply the subscripts by 2. And the formula becomes P2O5. Can you name this compound? Sure you can. If you said diphosphorus pentoxide, you're right on target.
I guess that about wraps this up. Of course, you will be doing some more practice over the next couple of days. For now, your chemistry quiz.
You will need a periodic table and a calculator for cumulative review question number 1. What is the molar mass of aluminum chloride? A. 62.5 grams per mole. B. 133.5 grams per mole. C. 116.5 grams per mole.
Cumulative review question number 2. The abbreviation used to represent a gas in a chemical equation is A, G, B, AQ, C, an arrow pointing upward, D, both A and C.
Make sure you have your math hat on as you answer question 1. What is the percentage of aluminum in aluminum chloride? A. 20.2%, B. 43.2%, C. 79.8%, D. 56.8%.
Number 2. Which of the following would be considered an empirical formula? A. C2H4, B. SN2O2, C. C3H8, D. C2H8.
Number 3. Which of the following would be the empirical formula for sugar, C6H12O6? A. C6H12O6, B, CHO, C, CH2O, D, C2HO2.
Number 4. A student works a problem and finds that a compound has 0.074 moles of carbon and 0.148 moles of oxygen. What is the empirical formula of the compound? A, CO, B, C2O, C, CO2, D, C2O2.
And finally, number 5. What is the empirical formula for a compound that is 18.7% lithium, 16.3% carbon, and 65.0% oxygen? A, LiCO, B, Li2CO3, C, LiCO3.
Well, our math hats had quite a workout today, didn't they, Mr. Mole? You'll want to keep practicing these formulas before next time. And be sure to bring your math hat next time when we learn to write molecular formulas and hydrate formulas. Hey, that sounds like fun, doesn't it? See you then.